or 6 number of practice will be there from your metrology side. Okay, that Kanesh will be better able to tell you. Right. So into this, the list of the experiment that we have is the first experiment, study of the force measurement using load cell. Typically, strain gauge load cell is used for measurement of the force, and then we have got one setup with us, which is used for a very demonstrative setup. It's not that high-end setup, but it gives the basic configuration of how the load cell, strain gauge based load cell works for the force measurement. So then that is to be studied as experiment number 1. Experiment number 2 will be study of the torque measurement. Again, it is based on the strain gauge based load cell. Then there is study of displacement measurement using the potentiometer. So there can be two different types of potentiometers, a linear potentiometer and angular potentiometer. So experiment number 3 will be consisting of two different components into it. One is a linear speed measurement, linear displacement measurement, and the angular displacement measurement. Right. Then experiment number 4 and 5 will be done on the same setup where there are two different transducers. One is a photoelectric transducer and the second one is the variable reluctance magnetic pickup, which is used for the speed measurement. So this is how we have got the 5 different practicals that needs to be performed into this. Say earlier, even the last year, what we have done is we have explained you. In the earlier one, we have explained that to respective batches. Now, what we have decided, because it is going to take a very long time, we are explaining this experiment to you as a complete class, right? And then for checking of your journals as well as the conduction of viva, that will be done for your respective batches. So now, if we consider 5 minutes time for viva for each group, then minimum 40 minutes will be required for one batch to finish up, and like that, then there will be 5 different experiments and there are 6 batches. So you can imagine the time that can be required for evaluation, the valuation of your or assessment of the practical terms, right? So this is apart from the one that we will be requiring for explaining the experiment, right? This is one issue. The second issue is, till last year, what we used to do is every batch has a few number of students which are locally present in Nagpur itself, the vicinity of the campus, college campus. So what we used to do is we are allowing 4 or 5 students from each batch. Those are resident here. They will come into the laboratory and they can perform, if it is required, they can perform the experiment and take your own readings, so that the readings can be given to the batches if required. Right, this is what we followed last year. A very few limited number of 5-6 number of students, those who are present from each batch nearby Nagpur, used to visit the lab. They are doing the experiment by their own. Once this is explained, and then they are taking the values in the observation table, and then observation table can be shared to complete batch then, right, for making the journal. So this is what the practice we followed last time. So this will be encouraged this time also. So 4, 5 or say 7, 8 students from each batch can be allowed to come into the college, come into the laboratory and do the experiments and take the readings, share the readings with the complete batch then. Any doubt in understanding till what I explained now? The general discussion on the topic. Now, I think we'll go for the first experiment. I'll explain you how this experiment and what is the setup that is available with us. Right. So experiment number 1 is a force measurement using load cell. This is the title of the experiment, and then that you have to write in your journal. When you have to take the journal pages from outside, and you have to start preparing your journal. So that will be force measurement using load cell. Then you'll have to write the aim of the experiment, that is to study the load cell trainer that is available with us, and the second objective is to study the static characteristics of the instrument, the measurement system for force measurement, right? So this is the aim. If you want, you can take it down here. Name of the experiment, first experiment. I think I have shared this to batch 2. The samples from this presentation I have shared with batch 2. You can ask them, they will share that to you again if it is required, right? So the first term in your the first title in your journals. That is the handwritten journal will be the force measurement in load cell. Then the aim of the instrument, aim of the experiment is to study the load cell trainer and to study the static characteristics of the device. Then introduction. Now this theory and application that you have to write down from reading in the textbooks, reading general about the theory of load cells. Say theory of the load cell. Now here the load cell is a strain gauge load cell. So information regarding this you can find from the textbook, from the internet resources, or from any other way. You will write something regarding the strain gauge load cell. Then what are the different types of load cells, how those are used. In brief, what is the working principle of the strain gauge. Then what are the different circuits used into strain gauges. You can go through textbook. It is a half bridge, then the quarter bridge, and then full bridge circuit. Okay. Now when you go through textbook, you will come to know the different connections. So it is nothing but Wheatstone bridge. The Wheatstone bridge and different connections that can be seen from the literature. So this is a bridge circuit wherein the input voltage is applied, say E in, and output is taken from this between the two terminals. Right. So this can be using only one resistance gauge RG, or it can be, say, then it will be quarter bridge. If it is half bridge, it will have two RGs. If it is a all four resistance wire, then it will be a full bridge. Then you will come to know the circuit diagram of this. You will write everything that you can write possible about the load cells, and in particular the strain gauge based load cell. Right. Then what is the compensation and all that you will find from the textbook. You write it down. Then you write the applications, for which application the strain gauge load cells are used. That is to be written in your journals. That is theory part that you have to find out from textbook or the internet resources you write. So especially theory and application that you are going to write. Any doubt in understanding this introduction part of your experiment? Set right up, I am saying. It will be title of the experiment, aim and objective, then introduction part, theory as well as application. You will draw all the circuits also, right? So you have to draw circuits also here. What is a quarter bridge circuit? What is half bridge circuit? What is full bridge circuit? Then how it functions. Okay. Anything say else that I am not able to recall at this point of time, but you can go through. If you want, you can write. Then the next part is the circuit diagram. Now what I mean to say the circuit diagram is, this is the device, and for this device this becomes the circuit diagram. Now this is the very block, the broad way of describing what circuit is there inside. Say it has got a power switch, then it has got zero adjustment, then input is here. Say between point A and B, whatever is the strain gauge here, the bridge circuit will have input from this strain, the physical strain gauge here. Inside there will be some circuit connecting here, and then we will get the output here between point C and D. It is given to the instrument amplifier. I think now you are able to understand at least what is the meaning of amplifier and what function is going to do. Right. Then through the amplifier we have got a gain adjustment, and then we have got a digital readout. Digital readout is here. So some signals are given, and simultaneously we can have the measurement of voltage. Actually this scale is calibrated in terms of volts, so that whatever voltage is shown here is corresponding to the load that is kept here in kgs. Right. So same thing, if it is required, we can have multimeter and we can connect these 2 points to multimeter and get the same reading that is shown here. Right. So those who will be visiting the laboratory from respective batches, they will be able to see this in detail. Strain gauge 1, 2, 3, 4. These are the strain gauge, means these are the strain gauge wires that are present here on the load cells. Right. So in actual practice, the load cell is something that is from the textbook you can find out. This is nothing but a bar working as or acting as a cantilever, and in between there is one recess provided here. one slot provided like this, so that it has got a minimum cross section here at 4 different points. And then I'm going to paste here strain gauge 1, strain gauge 2, and from bottom side 3 and 4. And then it will have some wires, strain gauge wire. Then those are connected in the bridge circuit. And this one side is kept very fixed. And on the other side, we are going to apply load W. Because of load W, it is going to deform. And due to deformation, there will be some strains induced which are going to change the resistance of this wire. It is del Rg1, del Rg2, and so on. Right, this is how it functions. So the strain gauge is shown here in actual physical device. And then this kind of description you will also give into your theory, into theory part. Any doubt to this point? Then we'll see the load cell. So actually load cell is nothing but something that is shown in earlier diagram. I'm not having very clear diagrams here, but still this is a load cell, this part. If I need to show it, please give me a time, then I'll be able to show you. So this is something, a load cell. It is this, I think you are able to see this one, right? So one end is made fixed, the other end we are going to apply the load. So this is the bar that is shown, and it is having the strain gauges. If you are able to see this one, these brown spots, these are the strain gauges which are attached to the same member. These are the strain gauges, this brown rectangular part, and then this is a circuit that is used for taking the input from. This is a broken one now. This is out of order. But this something is called as a strain gauge load cell that is shown here with the help of this red device. This one. Right. So this is a load cell, and then this arrangement. One panel is attached to the top of this. At this end, there is a panel attached, and then I am going to put some weights here. Now block diagram. Say you have to show here what is going to act as a primary sensing element, what is a variable conversion element, what is variable manipulation element, and so on. So you will represent everything in the block diagram, and then you will show at input what is signal available and how the signals are transferred, what is signal here, type of the signal from each of the place that you have to give. This is called as a block diagram, representation of the instrument. Functional block 1, signal available at the end of functional block 1. Functional block 2, signal available at the end of block 2. That is at the entry of block number 3. Then block 3, signal available at the output of block 3, and so on you have to give. And last will be the display panel, and here is the observer that he is going to observe something here. Right, so this is what is the readout that is given. That is called the block diagram. Any doubt in understanding what is a block diagram? I think this we have studied already in our earlier classes. Primary sensing element, the variable conversion element, and so on. So this pattern will remain there for all the 5 experiments. Whenever it is block diagram, you have to represent this in the form of input to the each block, output from each block, and what is the type of the signal available. Any doubt in understanding what is the meaning of the block diagram? Right. Then you have to write the procedure. If you want, you can take down the snapshot. I think this I have shared you. I have shared with batch 4. Sorry, batch 5. So to some batch I have shared today. So you can ask that. It is a procedure. So in the procedure, what is that? We have to make on the switch, you have to adjust 0, put the small weight, say for example 50 gram each in the pan, and note down the display reading. Then we have to put multimeter on the output voltage slot, that is the slots provided, and take out the reading for the given load. We have to carry out the same process for each interval of 50 grams till it becomes 600 grams, the maximum weight that is available in the laboratory, in the step of 50 grams. This is called an upscale reading, that is from 0 to higher load. And then we have to come down reverse way. We have to remove one load each at a time. till it becomes 0. That is called a downscale reading. So we have to note down the reading for upscale and from downscale. Then we have to prepare observation table, and to do the calculations for static characteristics, we are going to prepare a graph for hysteresis. I think this now we are going to learn shortly, but at least at this point of time you try to understand something you have seen in electrical engineering, hysteresis. So same thing is going to occur here. The upscale reading, the nature and the graph for upscale reading, nature of the graph for downscale reading, it is going to give the hysteresis curve. Right. Then what we will do is next you take down this observation table. You can take a snapshot if required. I have shared this already. What is that serial number in the load gram 0, 50, 100? Likewise, we have to go on increasing till it becomes 500 or 600. What is the display reading in the panel, and what is the output voltage shown by your voltmeter, correct? So this is from the setup, experimental setup, and this is from the multimeter, reading from the multimeter. So this is what we are loaded till 600, suppose now 600 grams or 500 grams. So it will start from here, 500 or 600 grams, whichever is there. You will note down. Then it will be 50 less than that. Say it will be 550, 50, 600, 500, and so on. We are going to make it 0. We again note down the reading on the setup of the display setup and the output from multimeter. So this is what is the observation table. Then we are going to calculate the accuracy. Now what is accuracy? I think that we'll see in some next week's classes. Full scale accuracy, true scale accuracy. We are going to find the precision. We are going to find bias, hysteresis, non-linearity. Right. So this part that will be more clear to you when we go for theory class. So you have to bother right now about this. What is important that you must be in a position to have the observation noted from the video or observation shared by your colleagues that they are going to perform here. Right. So accuracy, this thing we are going to calculate. Then we are going to provide the graph. This graph will be for upscale reading. Sorry. Upscale reading. And then this is for downscale reading. Right. So this is something called a hysteresis. So it is output and this is input. What is the output here? It is display that is given by the setup or say multimeter. And what is the input? This is nothing but load. Load versus the indicator, the values indicated at output in kgs or in terms of voltage. It will give the similar reading, right? So this is what is to be done. Graph is to be plotted. Then in the result and discussion, what we are going to write is something regarding what we learned from the experiment. That is, say strain gauge load cell is studied. The different models of strain gauge load cell operation have been understood. The loading and unloading pattern is studied. Then static characteristics are calculated, and then the hysteresis plot for the mode of operation is found out. So this is something that you can write as a comment. Right? So you are going to put the comments here. So it will be followed by comment 1, 2, 3, and so on. It is nothing but your observation and conclusion remark. Any doubt in the process that we are going to carry out here? If there is no doubt, then I'll be able to say share the video with you. This is just for explanation, right? So I'll share the video now. Right. So I'll share. Is visible to you now? This video is visible? So see now, this is the experiment setup that we have with us. So what is there? Who is there? Rathan Raj. Rathan Raj, you want to sing something? Probably something from Pushpa? Pushparaj, some who is there?
Sorry, sir. It was
Hey,
just
it's
bad.
welcome. Say, we can have this kind of class also but sometimes, huh? Where you will be able to freely share something that from your side. All right? Okay. So see here, the display panel, the multimeter is connected from between the two, points here, the terminals given, and then this is the load cell that I have already shown to you. So we are going to put some weight and we are going to take the reading. Now this zero adjustment and the gain adjustment is for asserting now. See, for example, now the load is not there on the panel, but it is showing some value. So to have proper adjustment of the amplifier, we need to adjust the gain, and then we have to also adjust the zero setting. So you please pay attention to this, the video that has been shared. So what is done, we are going to connect first multimeter zero adjustment. Say what I have done is zero adjustment here, so that now it is showing 0 kg. Attach the multimeter with this, and the reading from the multimeter is seen, so that it is going to show 0 volt. Okay. Now I am going to add the weights. The first weight 50 gram is added. See, it is approximately the same value shown, 0.5 volt. It is 0.1 volt. Here it is 100 gram, 0.1 kg, it's 0.49 kg, 0.15 volt. You can note down if it is required. You can have the rough estimation from the video itself. I'll play it again for you, don't worry, but you pay attention and start noting down. And the next weight, it is going to make approximately 500 gram, that is 0.5 volt shown. I have added 100 directly. Last weight is 100, so it is 597. I have removed one. See here, it is 600. So for 600 grams, it has shown 0.597 grams and it is approximately 0.6 volt. Then I removed the one. See the reading here. .399. Again 100 gram weight is removed. Again 50 gram weight is removed. It's just for clarification of the process. The real reading that can be shared with you is with the help of the batchmates. Those are present here nearby Nagpur. They can come and perform the experiment and get the observation table, the correct observation table for them. Right? So this is how we have performed. Any doubt in understanding the process, the procedure? Okay. So I'll be able to show it again. You pay attention now. See, I have used first of all the zero adjustment. I have made circuit on, use zero adjustment, then use the multimeter to get the reading. You may please note down the reading now. If you want, I will be able to stop at that particular instance. Say first zero, a certain zero everywhere. 50 gram weight is given. Reading. Second one. Third one. fourth one, fifth one, that is 250 gram, 300 gram, 350, 400, 500, and then 600. So last two steps we have got 100 gram as upscale reading. We have appended that. Then we have removed. So I hope you are noting down the readings, and then also you will be getting the reading from your colleagues, those who are interested and those who are nearby Nagpur and willing to come and do experiments for complete batch. So this is how we get the readings. Now there was little difference into the reading shown. So for example, the display here. So that may be because of some lag into the system or some kind of error that we are not going to comment right now, but we need to identify why there is an error. Any doubt into this? Okay. So this is how we say that we are going to have the experiment number 1. At least I have shown you how the experiment 1 is performed. Right. Then I will go for the next experiment. What we are going to show into it. That is a torque measurement. Measure the experiment as per the list goes. It is the measurement of the torque. Are you able to see this? The screen is visible to you? The screen is visible to you or not? Any reply from your side? So this is a torque measurement using again strain gauge. So here also the theory more or less remains the same as the earlier say experiment. When it is strain gauge, then strain gauge equipment that you have to explain. So the title of this experiment number 2 that you are going to write in your experiment journal, torque measurement using strain gauge. What is the aim? To study the torque measurement system and its characteristics. Again, the characteristics are the static characteristics. We are not going to take any of the experiment for dynamic characteristic measurement, right? You always keep in mind that the characteristics are the static characteristics of the instruments. Then into this theory, if what you are going to write, what is the strain gauge based, what is the load sensing devices in general, you have to give a list. Out of that, suppose now this is the particular one using strain gauge, then how it functions, what are the different types and so on. Like types of the torque measuring instruments, the strain gauge, load cells and its type, describe the circuit diagram, like the quarter bridge circuit, half bridge circuit, full bridge circuit, their operation, similar to the earlier experiment, and bridge circuits. Then what are the peculiarities of bridge circuit, whether compensation is required or not, and so on. And what are the applications of those torque sensing load cells that you are writing theory. Okay, so I think you can have a snapshot of this if you require. This is something in your experiment number 2. So aim of the experiment is to study the torque measurement system and its characteristics. Title, torque measurement using the strain gauge. Then the similar experiment setup is here. This is a separate device that is used for measurement. It has got a power supply, on off switch, zero adjustment switch, input switch. The input is given from the load cell, wherever it is, and then output is measured between point C and D. These are the strain gauge 1, strain gauge 2, 3 and 4. So the same diagram you can draw in your journal, exactly same as that of the experiment number 1. So into the circuit diagram, you will draw this diagram. You will show power switch, zero adjustment in this diagram, and this is the what is used for giving input here between point A and B. So from this, the input will be given to A and B. Then there will be instrument amplifier, then digital readout, and then here it will be the output for the multimeter. Output for a multimeter. Then this is the device. Actually, this device is something that is made in the form of cantilever. Say this is some setup, and then the load cell are attached here. This is a load cell, and to this load cell there is one extension arm is provided. So from this support, there are some hooks attached at distance L1, at distance L2, at distance L3, at distance L4. So when one of you will come actually here into the lab, he is going to measure the distance L1, distance L2, distance L3 here, and distance L4, and so on. So that suppose now if I am going to attach here a 500 gram weight, so 500 gram into L1 is nothing but the amount of moment that is going to act on the load cells, and that is what we are going to measure, the torque, the moment, twisting moment that is acting on this load cell. This is the load cell. So that is to be measured. So this is the diagram. Say this is now the one I have shown you, the load cell. It is attached at one point. One arm is attached and there are hooks, different hooks at different distances. L1, distance L2, distance L3 and distance L4 from the support. And then it is going to show the readout. So this is the load with the strain gauge. So a simple block diagram also can show for this instrument. Then load with varying distances. Say here it is, say 15 centimeter. This is 20 centimeter. So this is the distance here. So this is to be shown 15 and this 25, I think. So when somebody will visit here, he will physically count the distance in between the 2 points. Similarly, the distance between the other hook and so on can be found out. Right. Then block diagram. Again, here you will write circuit diagram, CKD, circuit diagram. Into circuit diagram, you will show on-off switch, then the bridge circuit that will be shown. So this is nothing but SG1, SG2, SG3, SG4. Then here you are going to show the input and the output will be given to the amplifier. That is what is the block diagram you have seen just now that I have highlighted here. This is the block diagram. Circuit diagram, sorry, not a block diagram, the circuit diagram. So this circuit diagram, same diagram you are going to make as a circuit diagram, and into the block diagram then you will draw the primary sensing element, input signals, then variable conversion element, the signals available here at the input and output of variable conversion element VCE. Then it will be given to VME or something, whatever is there into this measurement devices. Then it will be data transmission, data presentation and so on. What are signals available, you have to draw it here. This becomes your block diagram. Right? So there will be two different diagrams, circuit diagram and the block diagram. Any doubt in understanding what is meaning of circuit diagram? The one shown on the instrument, that is a basic configuration of the connections available. Block diagram is functional blocks for that particular type of measurement system. Then procedure. Then you can write down the procedure if you want, or I will be able to share this even. You can take snapshot, that is better. So connect the sensor module to the measurement unit, switch on the power, adjust 0. I think you can recall the earlier experiment where you adjusted 0. After 0 adjustment, we have given the load. In this case, hook the weight of 1 kg to the cantilever in the provided slot from 5 cm to 20 cm. right? And note down the output voltage respectively. Repeat the procedure for 0.5 kg load and tabulate the results. This is the procedure. I hope you have taken the snapshot. Then coming to the next part, the observation table. Now in this case, when the weight is 1 kg and when weight is 0.5, distances it is 50 millimeter, 100 millimeter, 150 millimeter, 200 millimeter, respectively here also. On hook number 1, 2, 3, 4, hook number 1, 2, 3, 4, that is 50, 100, 150 and 200 millimeters. Then torque, you can find, say, weight into the distances, you can find the torque, and what is the output voltage shown by the instrument. Maybe panel readout or the voltmeter readout, one the same. So you can take the observation. You can take a snapshot of this also. So that now you will be able to fill up the readings that is given, that you can note down from your videos, as well as you can perform the experiment actually and take the readings. No issue. Right? So I think I should move ahead. What are the calculations? We need to make the accuracy. Full scale, true scale accuracy is to be predicted, precision is to be given, bias is to be found out, percentage nonlinearity and the sensitivity. So again, this we can correlate when we will go for the study of this kind of static characteristics. Probably next week we will start for this. Accuracy, full scale, true scale, precision, bias, nonlinearity and sensitivity. That we will find out. Okay. So results and the calculations. Say here we are going to discuss what are the main experiment contribute the finding, and then we are going to put the graphs of torque versus output voltage for 1 kg, torque versus output voltage for 0.5 kg. So there will be two different graphs that you are going to plot, right? So I hope you are also simultaneously taking down the snapshots of this for your references. Right. So here, so this is the list that you have to follow in very first practical also. All practical you will find. It will be first title, then aim. Introduction, circuit diagram, block diagram. I have explained you what is the meaning of circuit diagram, what is the meaning of block diagram. Then procedure is to be given, then observation table, static characteristics calculation, then you have to give the graphs, results and the conclusion. So this is what you have to write in the journal in all the practicals, all 5 practicals. This is very general. I think this might be known to you from the tradition, from say 10th, 12th standard and so on. It is the same that we are going to find it out here. Now what is important in all these experiments, that we must be in a position to find out what is the application of this kind of load cell and where it can be used. So for example, there is some task in industry wherever you work. Suppose now you are going to use the strain gauge based load cell. Then we must be in a position to find out the characteristics, and then we must be in a position to see how accurately the measurement can be taken. So when we will study the portion on the errors and other portion, you need to correlate what are the different kinds of error that can be incorporated in these measurement systems so that the output is deviated. What are the means and ways to reduce down that spurious input that is going to enter into the system, how it can be maintained at accuracy at the given desired accuracy level. So these are the basic questions. Those setups are very simple, but we need to think on from that perspective. Right. Then I think this is what is the discussion on experiment number 2. Now let us see how it is performed. We have got some sample videos with us. So I think I will share that to you and see this one now. So I will share this. think you are able to see the screen now. See, this is a setup. The similar circuit diagram is here. The same thing we have done. The output from this is taken and it is given to the main instrument measurement setup here. This is the entry of the signals. Say we can observe this now. So we are going to make the switch on, then we are going to have the zero adjustment, which has shown 0.04 something. We have to adjust that to 0 first. Right, now see this voltage also 0 and display also 0. This 500 gram weight along with hook that is attached at 50 millimeters. So the torque shown is 0.1, here is 0.11 volt. We observe this carefully. Now the same is attached to the second distance. Attached to a third distance then. You can also see the readings. It's 0.71 and 0.7. Fourth. Right. Then we'll add the weight. So this is the observation for 0.5 kg. Now it will be 1 kg. Another 500 grams is added. So at first distance, 5 centimeters, 0.23, 0.23. So I hope that few students will be able to come and perform this experiment also in the laboratory and get the readings verified by their own say observations. 0.3. It's 20.4. See, it's showing something higher value. It's 20.06, 20.04. Right. So this is what is the observation. I will repeat this once again. You please pay attention. Zero adjustment is used. Right. Now we'll again increase the weight. right? So this is how we are going to perform the section number 2. Anything that is not clear in this one? What is to be done? What is the procedure? What is to be written here? And what is the objective aim for this section number 2? So it is to-do list for the journal will remain same. Now I can say share the things for practical number 3. That is the displacement measurement as per our experiment list. Right. Here the displacement measurement using the potentiometer, both kind of potentiometer, that is the linear as well as the angular potentiometer. Now when we will study this, the displacement measurement using a potentiometer, you need to find out the theory from the textbooks. It's the simplest kind of the transducers, those are used for displacement measurement. Potentiometer is very much linearized transducer for displacement measurement. So we'll write the aim of the experiment as study and study of displacement measurement using the potentiometer. Then the next is aim, to study the displacement measurement using potentiometer. Study the characteristic. I think you can write 2, the first and the third. You may write this first aim, and then next aim is to study the static characteristics of the linear and angular measurement displacement devices. That is the potentiometer here. Now into this theory, you again write down the type of the equipment used for general linear and angular displacement measurement. So these generalized instruments and the measurement systems used for this, you will discuss. And then you will discuss regarding the potentiometers. As the device for the displacement measurement. Then working principle of this potentiometer, both linear and angular, needs to be given. This you can find from any other textbook or the internet resources. You have to draw the circuit diagram and the bridge circuit that is used for connecting the potentiometer to the input and output signals. The output signal, that is output voltage, is to be measured. So you will write down, you will draw the bridge circuit with the help of the diagram given in the textbooks. And then different applications. What are the characteristics and how it is applied for the task, a different task. Application you will give here. Anything that's not clear, what is to be written in the introduction part. Right. So into the do list, you are having the third element as introduction. Then the setup. Then this is the block. And then this is a circuit diagram for the angular displacement. You can take a snapshot of this. So this is a potentiometer, a highly accurate, a better precise or better accurate potentiometer is shown here, which is having some rod which is going to have linear displacement. Here it is a potentiometer, the degrees from 0 to 300. This is a setup. Then this circuit diagram for the linear displacement. So this will be given from the voltage measurement. Then this will be the output in terms of the displacement. So what is the change in the length of that bar? It will be given to the instrument now. So it is given here. The sliding bar is going to govern this displacement with respect to the resistance coil. Potentiometers is what is the block diagram for the potentiometer, the circuit diagram of the physical configuration. And then this is the sensing device for or measurement of, say, at least rough estimation of what is the input given. So this graduation will be corresponding to the level of the washer here. Then this is for the angular device. So this is a potentiometer, then where there are the graduations with respect to degrees, and we are going to give the input from 0 to 300 degrees. Now into the block diagram, you will give first circuit diagram and second it will be block diagram. Into the block diagram, you will give the functional block, primary sensing element and so on. Input signal available here and so on. The last one is the display device. Procedure for angular measurement, we have to switch on the supply, connect the digital voltmeter at the output. We have to vary the knob of the potentiometer from 0 degree to 360 degrees in steps. We can take the steps of 5, 10 and so on. And every time we have to note the output voltage. We have to tabulate the result. Now though this device is very simple, but you will find that this is very largely used device for getting the position and angular orientation from the different sensing devices, say different instruments. So potentiometer can very conveniently be used for, it is the simplest device and is reasonably accurate. So that is the reason, being simple, cheap and say very effective device for measurement of the displacement, maybe angular as well as the linear displacement measurement. Now same procedure is here. For linear displacement, we have to switch on the supply, we have to connect the voltmeter at the output, we have to vary the knob for linear potentiometer from 0.5 centimeter to 5 centimeter in the step of 0.5 centimeter, that is 5 millimeter each. We are going to give the displacement and note down the voltage reading. We are going to tabulate the result, and at the end the observations are in terms of degrees, output in terms of voltage. If you want, you can make the separate observation table. Here again it will be serial number 1, 2, 3, 4, linear displacement, output voltage shown. Okay. So you can have this column 1 and column 2 for observation table 1, and for table 2 column 3 and column 4 only, serial number column 3 column 4, like that. So again the same static characteristics we are going to find out: accuracy, true scale, full scale, precision, bias, non-linearity and the sensitivity found out. Okay. Then graph of angular displacement versus output voltage, linear displacement versus output voltage will be drawn, and then conclusion will be given. The potentiometer is found to be more linear, non-linear. What is your finding? It may be linear device as per your finding, it may be non-linear device as per your finding, and so on. That you are going to write it down. Right. So this is what is the setup and the elements to be written into the journals. So here also the title, aim, introduction, circuit diagram, block diagram, procedure, observation table, static characteristics, and the graphs are to be given. Then result and discussion. These are the things to be written. You can take the snapshot of this. This is example number 3. And then we can see the one how the experiment is performed. I think I'll be able to show that also to you. Number 3. Let us see first of all the linear displacement and then the angular displacement. I have the screen visible to you. Now see the linear displacement. First of all, what is done? Switch is made on, and then output voltage. I think displays some. There is some problem with the instrument display. That is what we have to rely. We want to rely only on the reading shown through the voltmeter. See the displacement given 5 millimeters. It is going to show the exact 1.5. You can see the observation. Wait. I'll show one more to you. Just a moment. You can see this. I think display is not that clear, but still you can observe. See, it is reading 0.5. 0.50 for 5 millimeter. You can perform. When your colleagues will come and they'll perform the experiment, they will come to know clearly. It is 5 millimeter input here, and it is 0.50 as the output here, as shown on the voltmeter. Here is 1 centimeter, that is 10 millimeter here on the scale, and similarly the reading shown here is 1.01 volt. It's 3.5 and the reading is 3.55 volt shown on the display. And this is the last reading. Is 4.75 volt. It has shown for 5. Sorry, no, it is for 4.5. Okay, so this what is the measurement for linear displacement. Shall I show it once again, or that is clear to you? I'll go for the angular measurement. The screen is visible to you now. This what is angular displacement measurement. You have made this circuit on. Voltmeter readings. Say for 30, it is showing 0.22. 60, 0.53. In 90, 0.84. For 120, it is showing 1.14 volt. Two 240, and 270. Okay, I think now we will be able to show again with displacement also, both. Okay. Anything that is not clear? Wait, I think I need to show it to you. By some mistake, it has gone out of unshare. I'll share it again. Right. In the circuit diagrams. Now we have two more experiments left or to show you. Right. So I think I'll show that to you. It will take another say, 35 minutes it will take. So then I think we'll be able to finish up everything, at least from demo point of view, to you by today itself. Okay. I'll go to the experiment number 4. That is nothing but speed measurement using photoelectric cell. you can take the snapshots of this. So study of the speed measurement using photoelectric transducers. Now, though it is the experiments we are performing here, you are required to go through the textbooks for understanding what is meaning of photoelectric transducer. So it works on certain principle where the light is emitted, and if it is abstracted at certain rate of the time, it is going to perform, or it is going to produce the pulses of electrical current, and then that current is going to be calibrated in terms of the time event. So for example, into a disk there are 10 holes, or there are 10 slots. Then the incident light that is passed on from source to the collector, and the plate is placed in between, that signal will be interrupted 10 times in a single revolution of the disk. So with this rate of measurement, we can find out the speed of the disk which is connected to the motor or the device of which speed is measured. So then this is called as a photoelectric transducer. So it is working on the principle of the light, emission of the light and collection of the light signals. So this is what is the theory that we need to find out from the textbooks. So what is the aim? You can write here first and the third point here, the speed measurement using photoelectric transducer, and to have the static characteristics of the instrument. These are the intentions behind conducting this particular experiment. Then you have to write down theory. What is the speed measurement technique in general? Speed measurement, and then what are different techniques for speed measurement, out of which the photoelectric transducers. What are the photoelectric transducers, how they function, and so on. Types of the speed measurement devices, working with speed measurement instruments. We have to discuss in particular for photoelectric transducers, their working principle, functioning, and so on. Right. Then we have to draw the circuit diagram for the experiment setup and its bridge circuit. We have to give the applications of this device, especially the photoelectric devices, for speed measurement. What are the merits, demerits, and advantages, disadvantages, the characteristics of the instrument, some comment regarding the static characteristics, linear, non-linear, analog, digital, and so on. That is expected here. We'll go through textbook and find it out. Then this is a setup. Now you can have the snapshot and you can draw the circuit diagram. So this is one basic diagram for the working principle of the device, and then out of this there are two different transducers. One, this is for the next experiment, that is experiment 5, that is called as a variable reluctance magnetic pickup, VRMP, I have abbreviated here. Whereas this circuit is for the speed measurement using photoelectric pickup. Now the instrument is having two different components. The first is the display panel, and the second one is the speed measurement where the motor is connected to the disk. So this is the one end that is we are going to use in experiment number 4. As I have discussed, there is a motor and the disk on which there are some holes made. If that disk rotates once, suppose there are 10 holes, then the signals from the optical source and the collector will be disturbed or will be broken 10 times in one rotation of the disk. And then this what is a photodiode. This is the input signal that it is connected through this circuit. It is given here, and this is a disk. Then the signals are collected here. Say this is the collector here somewhere, the red dot I am showing, and then it is connected to the circuit here. Is going to take the signals, and then signals will be given to the circuit here, that is amplifier circuit. So this through the amplifier circuit, the signals will be amplified and then it is given to the digital counter. So this is what the first and the next terminal for the digital counter given here. This is given to a digital counter, and simultaneously we can have voltmeter connected at these points to measure the voltage. Any doubt in understanding the circuit diagram? We are thinking of the first part, that is say part A, I am going to call. This is the connection circuit for the physical element that is shown here for part A. So signals are given from this to the magnification circuit. Then there is an amplifier with the help of the transistor and the amplifier circuit. It is given and then proper filtering is added. It is given to display panel and as well as voltage is taken out. So this is a motor. So this is the emitter and this is the collector. These are the two elements. Say light emitting device, light collecting device or signal collecting device, and this is the disc attached to the motor. This is the tachometer that we are going to use. Say for measurement of the speed at the shaft, we need to connect the tachometer here. And that tachometer is here. This is the contact type of tachometer that we are going to use. So block diagram, again it will have two different part, circuit diagram and second is a block diagram. So again it is going to be the same, input, primary sensing element, output something, then the signal available at output, the second phase, again signals will be transferred to the variable correction element and so on. This is the block diagram. In the circuit diagram you will draw everything that is shown here. That is by means of this part C in this rectangular block and part A, that is for potential pickup, speed measurement setup. Right. In the procedure, you can go on taking the snapshots so that you will be able to remember what's written. So you have to connect the transducer and motor unit. There are two elements, controller unit where I have shown the red lines, red line with part C and part A, and the motor where there is emitter collector and the disc with the help of motor is attached. So there is motor unit. Connect the transducer and the motor unit to speed measurement devices. You have to switch on the power. Connect the output of the totality pickup, that is point X, to the photovoltaic cell, the FVC at pin 1 and Y to the ground. So this is a notation given on the circuit. G and D stand for ground and this stands for the positive voltage for the circuit. FVC and the ground, you can see it here. V in, this is FVC, if you are able to see this. It is shown here on the actual device. This is what FVC and the ground. So coming back to the procedure, rotate the speed pot and adjust the speed with the help of tachometer. So see into this, we are having a speed adjustment knob here. As we increase this, the magnified signals are given to the motor so that larger voltage gives the speed from 0 to the full speed of the motor. So through the speed adjustment we vary the speed from 0 to the rated higher speed. That is what is told into the procedure. And adjust the speed with the help of tachometer. Then increase the motor speed in proper steps. Whatever is shown in the display. Suppose now I am going to take the speed in RPM. So with the given steps, 5 RPM, 10 RPM, 15 RPM and so on, we are going to have the increment in the speed in steps and note down the display panel reading as well as tachometer reading for the given speed. Then respective voltage output is also noted down from the voltmeter and it is tabulated in the observation table. So observation table, measure speed by photoelectric transducer. It is a display panel of the instrument. Measure speed with the help of tachometer, and the output voltage in terms of multimeter reading. It is noted down. So display panel reading, tachometer reading, and multimeter reading is taken for each of the step of the speed variation. Any doubt in understanding this observation table? Right. Then here also we are going to find out the static characteristics like accuracy, FS and TV, that is full scale and true scale, precision, bias, non-linearity, sensitivity. So this is going to remain constant for all 5 practicals. Result and then graph. So we are going to give the graph of measure speed of by the tachometer versus voltage, measure speed in the display panel of the photoelectric transducer readout versus voltage. So there are 2 different graphs we are going to plot. And then those graphs will be plotted on single graph sheet. We are going to superimpose and then we are going to compare the result. Say possibly one graph will be something like this, the other graph will be with other nature. So we have to compare these two, graph 1 and this graph 2. So whatever you got, I will give the example. Any doubt in understanding this process? So again, you write title, aim, introduction, circuit diagram, block diagram, process, observation table, static characteristics, calculation. You are going to put the graphs, result and description. So this remains same for all the 5 experiments. I think you have taken down the snapshot of this one. Right. So I think I will share now. The process, how it is done. Think screen is visible to you? Just now pay attention. We have made the supply on, and we have made the connections. Ground and V in is connected to FVC. We adjusted the speed first. See, for example, the speed is adjusted so that now it is going to show 2 RPM from 0. Speed started the picking up, and the speed is measured with the tachometer. So it is now for 4 RPS. We have got 0.04 volt reading and 250 RPM, 0.05 is the reading. Pay attention now. Next step is 6 RPS. Voltage shown, so 0.07, 0.06 something, 0.06 and 7 fluctuating. Next step, 8 RPS. For 20 RPS, it is going to show 0.21 as a volt and 1078 something as a RPS value, RPM value. This is the full speed. Shall I play this again, or is it clear to you? Any input from your side? Shall I play it again? There is no response from your side. Am I audible to you all? Right.
Yes, sir.
Okay. So no need to show it again. I think you are able to see how it has been performed and what are the readings. And I think similar thing we can see now here for experiment number 5, though it is something we are trying to do everything on a single day. But anyway, you are free to ask me to show it again and to repeat it again. I'll be able to go for. So I think I'll go for experiment 5 so that we need to again wait for some other half-hour slot for complete class. Right. So I will take this as the last experiment that we are going to perform. Variable reluctance magnetic pickup and speed measurement using this. So this the objective of the experiment, the title of the experiment, study of the speed measurement using variable reluctance magnetic pickup. Now, variable reluctance magnetic pickup is something wherein there are some magnetic flux lines produced by the transducer, and then if the disc is there where there are some kind of gear teeth profiles made on that disc, if that is coming in front of the magnetic pickup flux, there will be change in the flux density. Signals will be interrupted, and when it will be received, it is going to generate differential voltage. When it is in front of and the signals are blocked, the voltage generated by the receiver will be something different than when it is in front of the clear passage. The magnetic flux line collector will be some with higher density, so that higher voltage is induced. So it will be high volt, low volt for each teeth that is coming in front of the receiver. And suppose now there are 10 different teeths made on the wheel over the periphery, then there will be 10 times high and low voltage generated into the particular the rotation of the disc. And then we can calibrate and we can measure the speed by this rate of generating the signals. That is called as a variable reluctance magnetic pickup device. When you go through textbook, definitely you are going to go through textbook, you will get more clarity of how the VRMP works. So the aim is to study the speed measurement using VRPM and study of the characteristics. If you write this also, that's fine. The third also, to study the circuit diagram and the block diagram. So into theory, what you are going to write, the working principle of the speed measurement devices. This is more or less common as your earlier experiment. But here it is an addition here. VRMP, variable reluctance magnetic pickup, will be an added part to be written into the theory. Then you have to draw the circuit diagram and its bridge circuit with the description, the proper functioning you have to explain. You have to give the applications of this measurement device or speed measurement technique. Setup, I think I explained you earlier. This, if I am going to call this as the part C of circuit, and then this is part B of the circuit, shown with dotted lines. Part C and B of the circuit is used, same circuit. There is same motor say panel also that will be used. So I think you can take the snapshot and you will draw this as in the circuit diagram, this part B as part C. Now exactly similar to earlier, we have given V in to here to FVC that has been connected earlier. Now it is connected here, V out. And the ground is connected to ground of this V out of a variable reluctance magnetic pickup. Now what it is showing, the coil that is given with some electrical current is going to generate a magnetic flux. When this comes in front of the material, the reluctance, that is a back EMF produced, will be something different than when this recess comes in front of the pickup, and then the difference will give the pulse. Number of pulse per unit time is counted and then it's correlated with the speed. Any doubt in understanding the setup? Right. Then this is what is the elaboration of a motor panel. Is a disc having the perforations, having the slots or races, and this is the pickup. This is a variable reluctance magnetic pickup here. So when this comes in front, larger back EMF is created or the reluctance is created than when this slot comes in front of the pickup. So similar type of the same tachometer will be used again for speed measurement. So block diagram, you have to draw first circuit diagram, that is part C plus part B, that is I have shown with red colors on the instrument panel, and then you will give block diagram. Here there will be primary sensing element, the input entity, variable conversion, variable manipulation element, and the signal, change in the signals that you are going to draw. This is nothing but a block diagram. Then the procedure is more or less same as that we seen in the earlier experiment. Connect the transducer and the motor unit, to the speed measurement unit, switch on the power, make the connection of the circuit for variable reluctance magnetic pickup, calibrate the standard signal for the speed. First of all, we need to calibrate. Now for calibration, what we do at 0 speed, we see that 0 signals are achieved, that the display panel is going to show 0. And for full speed, that is for say 25 RPM, let us say, we should see that it is the display panel is going to show the 25 RPM speed. Then we adjust the gain accordingly. If it is showing less, we have to give higher gain. If it is showing higher value, we have to reduce down the gain. So that is nothing but calibration. We need to set the instrument for standard set starting point and standard set exit point or last end point of the measurement. Right. So we are going to match with the standard signals. Set the multimeter with FVC and ground and tachometer properly connected to the shaft of the motor. Then vary the signal potentiometer and record the display panel reading and the output voltage on the multimeter. And then slowly we are going to increase the speed in steps to tabulate the given information, the information into the given operation table. Any doubt in understanding this procedure? I think this is something new that I have talked here. For 0 speed, it should show 0 RPM. For larger speed, say for example on the motor, it is at 25 RPM. When I am going to have the speed knob to the full of its indicating value, it should show the largest value. If it is showing 32 RPM suppose, then I need to reduce the gain so that it will come down to 25 if it is the highest speed at no load. That is called as the calibration. This is something new into this. Then observation table is same as that of the earlier one. Measure speed from display panel reading. This what is the measured speed in RPM from tachometer. and this what is the output voltage from multimeter. Right. So then you have to vary in the steps. Suppose for 2 RPM, 0, 2, 4, 8 and so on, that you are going to vary the speed, and then you are going to measure tachometer reading, you are going to measure the voltmeter reading. The calculation as usual will be the entities like full scale and true scale accuracy, precision, bias, non-duality and the sensitivity. Then the graphs, measured speed versus voltage, that is display panel speed versus voltage, and the tachometer speed versus voltage, and display panel speed versus voltage. That we are going to plot on the same paper, and then we are going to compare the two curves. This is how it is the comparison to the performance. Yes, sir. Roll number 114. Do you want to say something? Any disturbance I am creating? Anything to be anything scheduled from your side at this point of time? I'm going to take another 5-7 minutes and then we'll stop. If it is difficult, you let me know. Roll number 114. Any difficulty from your side? Aditya, any issue in continuing for another 5-10 minutes?
No, sir. No issue.
Right. That 114 was, I think he's engaged with some other activity. Right. So I think you have taken the snapshot for this. It is going to remain same for all 5 experiments: title, aim, introduction, circuit diagram, block diagram, procedure, observation tables, characteristic calculation, graphs, results and conclusion, and the discussion on the results. Right. So again, I will be able to share the sample video that has been created for the class. Right. So I will go to the photoelectric pickup now. Share the same thing. Screen is visible, I hope. Right, so this is a connection now. Sorry, I have connected with the earlier video itself. I was supposed to go for magnetic pickup. Okay. Right. I'll share this. You pay attention now how it is connected. This is the part that will be the gear wheel variable rate as magnetic pickup. This is a motor unit, and this is the pickup. So speed is 0. So you see now for 0 speed, it should show 0. Condition is done. Slowly it has started to rotate 3 RPM. It's going to show 180. RPM and RPS is matching now, around 180. Yeah, 178. voltmeter reading. It's 0.03. It's matching with the display. For 2 RPS, that is around 120 it should have shown. It is showing 153. 3 RPM, 180 here and 0.3 volt. And I am increasing again. 4 RPS should be 240. It's 221 showing, 220, 221 something. Voltage reading 0.05. Speed is increased to the 5 RPS. 5 RPS. It should be 300, but showing 304, 306 something, 0.6 volt. Then 7 RPS. I'm sorry, 6 RPS. 300, but it's showing 312, 313 something. Eight RPS. Instead of 480, it is showing 430. Nine RPS. 0.09 volt. 477 something. 478, 488. Eleven. $660 it has shown instead of 660. 0.12 volt. 12. Sorry, for 13. Sorry, for 12 only. 12. Instead of 720, it is showing 672 and 0.13 volt. It's a full speed. So, say reading earlier to the full scale reading that can be taken in your observation tables. Now, let me any doubt in understanding this experiment. How we have performed. This was the demo setup that shown to you. The demo experiment videos are shown to you. Now, who's available nearby Nagpur, I will ask them to come down and perform the experiment. They can come right tomorrow. From tomorrow, they can start working on. So that you will be able to get the ready or say accurate results to fill in the observation table, and you can start writing up the journals. Right. So probably the day of conduction of the experiment, suppose, is tomorrow. Somebody from your batch comes and he performs that tomorrow. Then ideally we can have a week's time for writing the journal. And then we subsequently will start checking. Probably experiment 1 and 2 can be checked on the day 1. Experiment 3 and 4 can be checked on day 2. That is next turn to the particular batch. And then remaining experiment, last experiment can be checked to next of that term. Say suppose for example batch some batch is coming on Monday, so they will check first and second experiment on Monday, next Monday, third and fourth, next Monday it will be fifth experiment, and so on. So along with checking, we'll also conduct Viva. Okay, so you decide who else from your batch is going to come into the laboratory and do the experiment, so the sample experiment, and take and share the readings for your batch. Right. Any doubt into this one? Please let me know. If there is any doubt, you let me know. Otherwise, we'll be able to say close the meeting for today. Okay. So I hope that there is no doubt. If there is something to be discussed, you can put that on the practical group. If there is difficulty related to practical, we have made separate groups for the practical. You can discuss there, and I'll be able to give answers to you. Okay. Thank you for joining.